Okay, this is a review for section 10.1 to 10.3. So this section was all about naming polynomials by their first and their last name, and then adding, subtracting, and multiplying polynomials. So I am not going to go through the naming part other than to remind you that the first name was classified by the degree. So that could either be constant, linear, quadratic, cubic, or quartic. And then the last name was always the number of terms. All right, so if you are struggling with that, you need to look through your notes. You need to get all of the terms. But for the last name, the number of terms could either have been monomial, binomial, trinomial, or polynomial. So that is all I'm going to say about the naming stuff. Make sure it's in standard form. Make sure it's got a first and last name. You need to be able to identify the degree and the number of terms. So in terms of work that you're going to be showing for that, I want you to identify the degree and the number of terms, and then you can circle your answer. So for example, with number 4, my degree is 2, all right, and the number of terms is 3. So my first name has to mean degree of 2. Well, I know that that is quadratic, right? That is all what we learned about pretty much all semester is quadratics. And then number of terms is 3, so that is a trinomial. So number 4 here is a quadratic trinomial. That is answer choice B. But that's going to be what I'm looking for in terms of work on these types of questions. All right, let's move on to sum and difference. So sum means plus, difference means minus. So essentially what we're doing, unless we have to worry about distributing the negative, we're really just looking at combining like terms. All right, so x squareds go with x squareds, x's go with x's, constants go with constants, all that good stuff. So let's take a look at number 6. All right, number 6 I see as a subtraction. So I'm going to take that negative and I'm going to distribute it to all of my terms in my second polynomial. So I have 2n squared plus 4n cubed minus 6, and then I have a minus 6 plus 8n squared minus 8n cubed. All right, if you can look at your like terms from there and combine them, I am totally fine with that. If you want to line up your like terms and stack them on top of each other, I'm fine with that too. So 2n squared plus 4n cubed minus 6, that was my first polynomial. And my second polynomial, I had a minus 6, well that's a constant, so that's going to go with my other constant here, minus 6. And then 8n squared, that's a variable that's got an exponent of 2, so it needs an exponent of 2 with it, 8n squared. And then negative 8n to the third, that's going to go with my n to the third. Remember, I only want to put like terms on top of each other. If I had something that didn't have a like term, I would just have to put it off to the side by itself. But now I can combine my like terms, and I'm just going to add those together. So I get 10n squared, and then I get negative 4n to the third, and then I get negative 12. And the only problem with doing it this way is now it's not in standard form, so I need to write it in standard form. Negative 4n cubed plus 10n squared minus 12. All right, and then we're going to find that answer. So negative 4n cubed, so this is answer choice C. Okay, so you distribute the negative, and then you just combine like terms. And for 7 and 8, those are just addition. Drop the parentheses and combine like terms. Remember, when we combine like terms, it means that we add the coefficients, and the exponents stay the same. So combining like terms, that's a really important key right there. Combining like terms means add the coefficients and exponents stay the same. That's why you can only put ones that are the same together. Because if I try and put an x squared and an x together, how do I keep those exponents the same? I can't, right? So keep that in mind. Okay, the last thing for section 10.1 to 10.3 was multiplying polynomials. So remember, product is multiply, right? And remember that we're just doing the opposite of what we just learned in our last chapter, which was factoring. Okay, so finding the product, most of us ended up using the box to find the product. So I will give you the box on your final exam if you would like it. But remember, it just looks like this, and we're going to take our first polynomial and put it across, 3n plus 7, and our second polynomial and put it going up and down, 2n minus 1. Okay, then all we have to do is multiply. So 3n times 2n, that's going to give me 6n squared. 7 times 2n is going to give me 14n. 3n times negative 1 is going to give me negative 3n. And negative 1 times 7 is going to give me negative 7. Okay, and then I have my like terms on my diagonal. So I have 6n squared as my first term. Combine those and I get 11n. And then negative 7 is my last term. Remember, your first and last box are your first and last term. And those middle terms come from the combining of like terms right here. All right, so when we multiply, we're going to multiply coefficients, and we're going to add exponents. That's why 3n times 2n is 6n squared. Okay? If you do it the other way, if you do it by just distributing, that's totally fine. However you need to do it is fine. Numbers 13 and 14, you don't need a box at all, even if you don't use it at all anyway, because you're just going to distribute. It's a monomial times a trinomial, so you just have to distribute it inside. You guys have done that before. 15 and 16, that's the other kind of box that we used, so we'll just have 2 going up and down and 3 across. But you guys should be able to handle that. Look through your notes. You've got all the answers to everything. Email me if you've got questions. Okay? Bye!